Question 12 in Chapter 13 asks you to identify each of these sugars as a D or an L stereoisomer. Now, the word stereoisomer means a version of a molecule in three-dimensional space. So different isomers will be arranged differently in three-dimensional space. One example we've seen of that is the right and left-handedness of chiral molecules. That has to do with how the groups are arranged in three-dimensional space. And what we're gonna look at is in all of these chains, you'll have some carbon chain, and at the bottom you'll have a little tail, and just before that, we're gonna have a really key region. This carbon right here, just before the end, the last chiral carbon, is going to have an OH on it. If the OH is on the right, then it is a D stereoisomer. If the OH is on the left, so you have that little tail at the end, we are looking at this last chiral carbon. If the OH is on the left, then it is an L stereoisomer. And the significance of that is that these sugars are going to wriggle around and attack each other. The OH at the very bottom on the last chiral carbon, that OH is going to reach around and attack the carbon that has the double bond in order to make a ring. And whether the OH is on the right or the left side of the molecule is going to make a difference in the shape of that ring. So these are two big classifications. If the OH is on the right, it's an R. If it's on the L, it's a left. It's on the left. Sorry, yeah, it's on the left. Okay, so let's try it with A. We're going to look down. Here's that last chiral carbon, and on there we have an OH to the right. And because it's to the right, this is going to be D. The word for right in some Romance languages starts with a D. I think it's derecho in Italian, droit in French. So if you know a Romance language, you can refer to that. And that's a D stereoisomer, that's it. You could say D stereoisomer. Okay, this one. Let's look at the bottom chiral carbon, the last one down here. The OH on that carbon is to the right. And so this also is a D stereoisomer. Oops. Stereoisomer. For C, let's look down at that last chiral carbon. This one right here, not the one at the very bottom, the last one that's chiral, it's bonded to 4 different things as a part of the Fischer projection. The OH in this one is going to the left. And so this is an L stereoisomer. Going a little further down, same idea. So let's look at that bottom chiral carbon, not the one at the very bottom, but the bottom chiral one that's written with those crosses of the Fischer projection. The OH is going to the right, and so this is going to be a D stereoisomer.